Today we are going to understand alkanes, alkenes, and alkynes. Okay, so first we're gonna understand about the alkanes. So I'm writing here alkanes. Okay, here the word alk represents number of carbon. Number of carbon. Okay, it represents number of carbon. So suppose if we have one carbon, so we are using meth for that. Okay, here I'm writing here alk, ALK represents number of carbon atom. Carbon atom. Okay, if we have, suppose I'm just taking example, suppose we have one carbon. So for one carbon we are using meth. We are using meth, METH. If we had two carbon atom, then we are using eth. If we have three carbon, we are using prop. If we have four carbon, then we have to use but. It is not but, it's but. If five carbons are there in hydrocarbon chain, then we are using pent. If we have six carbon atom, then we are using hexane. Not septane. Septane is for 7. It's hexane. Not hexane. Only we have to use hex. If we have 7, then sept. Sept, or we can use hept also. Okay. If you don't want to use sept, then you can use hept. If we have 8 carbon, then you can use oct. If we have 9 carbon atom, then we can use non. If we have 10 carbon atom, then we can use dec. Yes. Okay. So alk represents the number of carbon atom. Okay. And here we have A and E. We are using if carbon have single bond, all single bond. We are using E and E if at least one carbon double bond is present. We are using Y and E if at least one carbon triple bond is present. Okay, carbon triple bond. Okay, so these three things you have to remember again. Alkanes, alkenes, and alkynes. Here N, in, and ine represent the carbon double bond, single bond, and triple bond. Okay, everyone. Okay.
Yes, sir.
Okay. So here we have alk and ens. So N represents carbon single bond. That means alkanes are saturated hydrocarbon. Okay, alkanes are saturated hydrocarbons. So I'm writing definition here. Alkanes are saturated hydrocarbon where all, or we can say where hydrocarbon contain all carbon single bond. Okay, are called as alkanes. Their general formula I'm writing here. Their general representation is CnH2n plus 2. Okay, where N, okay, where N equals to number of carbon. Okay, where N equals to number of carbon atom. Suppose we are considering the value of N equals to 3. Suppose we are taking N equals to 3. Then what will be our formula? So it will become C3H2 into 3 plus 2. So it will become
C3H6 H8
H3 into 2 is 6 plus 2 8. So it will become C3H8. Okay. So now again here we have 3 carbon. So for 3 carbon we are using prop. Is it? Is it or not? Prop. So I'm writing here prop. Okay. So see here, alk means number of carbon. So for 3 we have used prop, and we have to add A and E. So it will be propane.
Propanol.
Yeah, no, propane only. Propane. Propane.
Propane. Okay.
Yes, propane. Okay. So if you want to draw the structure for C3H8, you have to draw so like this: carbon, carbon, single bond. We have 3 carbon, and carbon have valency 4. So here that carbon, first carbon is completed only 1 valency. So 3 valency will be satisfied by hydrogen. So it will become CH3. Here we will have 2 hydrogen, and here we have 3 hydrogen. So this is the dash structure of propane. Or we can write CH3, CH3, CH2, CH3 like this. Okay, so we can write this also. Okay, so this is propane. This is the dash structure. That one is dash structure, and this is line structure. Okay, everyone. Am I audible, everyone?
Yes, sir. Yes, sir.
Okay. So take a screenshot for alkanes is completed here. Wait a second. Now we're going to discuss alkenes. Okay, alkenes. See here again, alk means number of carbon, and that E and E represents carbon carbon single bond. Okay, so if no, it is double bond, not single, it is double. E and E represents the carbon carbon double bond. Okay, if double bond is present, that means it is unsaturated hydrocarbon. Okay, so I'm writing here, alkenes are unsaturated hydrocarbon which have at least one carbon carbon double bond. Okay, at least one carbon carbon double bond. Okay, their general formula is CnH2n. Okay, so now we will understand example also. Suppose we have n equals to 2. Okay, so we will have C2H2 into 2. So it will have C2H4. Okay, so we have to draw the structure for that. So here we have carbon carbon double bond, and we know carbon have valency 4. So it will again combine with 2 hydrogen atom both the side like this. Okay, so here we have 2 hydrogen, so it is C2, and 4 hydrogen, so it is H4. So we have 2 carbon. For 2 carbon we are using what? We are using it here, it. See here, it. Okay, so we have to write here it. Yes, it. And for double bond we are using what? Ene.
Ene.
Yes, Ene. So
Ethene.
it will be ethene. Yes. Okay, let have one more example. Yes.
So for atoms, for the structure of an atom, how does double bond and how do they look?
Okay, I have drawn here only that structure. Okay. If you want to represent, you can represent CH2 like this. Okay, it is ethene. Polythene, you know, polythene is formed by many molecules of ethene.
Okay. Yes, sir.
Yes, so this is ethene, or this is the molecular formula. This is dash structure. Okay, this is linear structure. Okay. Okay, now we will have n equals to 4. So let's have n equals to 4. So what we will have then? We have formula CnH2n. So if n equals to 4, then we will have C4H8. 4 2s are 8. Okay.
C4H8.
Yes. So we have 4 carbons. So I am just drawing 4 carbon here like this. Okay. So here carbon have valency 4. So here 3 hydrogen will come. 3 hydrogen and 1
One is
carbon.
already occupied by
Yes.
1 carbon.
Here 2 hydrogen. Okay, here 1 hydrogen and here
1 hydrogen.
2 hydrogen.
So
Like
it already
this.
has a double bond with C, right?
Yeah, so here double bond is present here, no?
Okay, okay. Only 1 double bond, so 2 more are vacant.
Yes, yes. So now we have to calculate. See, we have 4 carbon. So 4 carbon is here. Okay. Then we have 4 carbon is here. Then we have 1, 2, 3, 4, 5, 6, 7, 8 and 8 hydrogen. Okay. So here again we have 4 carbon. So for 4 carbon we are using what? But. Here we have but. But. Yes. So it is but.
Butene.
And for double bond we are using ENE. So it is butene. Okay. It is butene. Understood, everyone?
Yes, sir.
Yes,
So
sir.
this is all. You can like have any number like 4, 5, 6, 7, 3, and you can have the alkenes. Okay, just take a screenshot for alkenes now.
Done, sir.
Answer.
Okay, sir.
Any doubt here in alkenes?
No doubt, sir.
Sir,
Okay.
for being the like for memorizing all of this, we should revise the table again and again, right?
Which table? That
The
one.
carbon table. Yes, sir.
Okay, see here you just have to remember the numbers. Meth is for 1, eighth is for, this is the you can say numbers from 1 to 10. Okay, 1 to 10 numbers only.
Yes,
Meth,
sir.
eth, pro, but, pent, hex, sept or hept, oct, non and dec. It
And
will help
sir,
you.
if we learn till C4 but, then a pentagon has 5 sides, hexagon has 6 sides,
No,
heptagon 7 sides.
hexagon, they are cyclic structure. We will discuss later on that. Okay.
Yes, sir. But by the
Yes,
name,
sir.
easy for memorizing. That's it.
Okay. Yeah. But just to remember, it will help you out up to 12th BSc, and whenever you will have chemistry in your syllabus, that will help you out a lot. Okay.
Yes.
Yes, sir.
Now we're gonna understand alkynes.
Triple bond.
Yes, alkynes. So alkynes, again, alk means number of carbon, and that YNE represents the carbon-carbon triple bond. Okay, so again, triple bond we have, that means alkynes are unsaturated hydrocarbon. So alkynes are unsaturated hydrocarbon, okay, which have at least one.
triple bond.
Yes. Uh-oh. At least one carbon-carbon triple bond. Okay, at least one carbon-carbon triple bond. The general formula. So general formula for alkynes is CnH2n minus 2. Okay, so let's have one or two example. So I'm just taking n equals to 2 first. Okay, so if we'll have n equals to 2, then we have formula CnH2n minus 2. So it will become C2H2 into 2 minus 2. So it will become C2H, 2 to the 4 minus 2 is 2. So it will become C2H2. So now we have to draw the structure. So carbon-carbon triple bond are present, and here one hydrogen and here one hydrogen. See, carbon are bonded with 4 bond, okay, and triple bond with carbon-carbon and 1 bond with hydrogen atom. Okay, so carbon will always form 4 bonds. Okay, 3 here
Yes,
and 1 here. Yes. So this is again, we have 2 carbon. So for 2 carbon we are using it, and for triple bond we are using INE. So it will be ethine. We have n equals to 3. So formula we have CnH2n minus 2. So it will become C3H 2 into 3 minus 2. So C3H, 3 2s are 6 minus 2 is 4.
4.
So we have structure again, 1 carbon, 2 carbon, and here we have triple bond. So here 1 hydrogen will come and here 3 hydrogen. Okay. So that we
Yes,
can
sir.
write that formula as HC triple bond CH, and here we can write CH3C triple bond H, CH.
Propyne.
Like this. Yes. So again here we have 3 carbon. For 3 carbon we are using prop, and for triple bond we are using YNE. So its name is propyne.
Propyne.
Yeah. If you will take 4 carbon, you will get butane, pentyne, etc. Okay. So this is all about the alkynes. Take a screenshot.